Okay, so I wanted to go through this worksheet because what I like about this is it takes the same problem and it revolves it around a bunch of different things. So you can kind of see what happens like depending on where the axis of revolution is. So before we kind of go on with this, I want to flip this sheet over and we're just going to summarize the disk method and the washer method and like what's similar and what's different and how we think about them, okay? So one thing we need to look at is like how do we know that our integral should be in terms of x versus how we know it should be in terms of y. And then we'll talk about how we know it's a disk method or how we know it's a washer method, okay? So if we're setting up our integral, I have from a to b of something dx, or I could have the integral from a to b of something dy. And how do I know my problem is going to be in terms of x? It's top minus bottom dx. These are x values, so the interval is left to right. So this would be the problem that we're doing if this is a difference between two curves, right? Okay, so that means that this one would be right minus left. And the a and the b value would be y values. So our interval would be from down to up. Now, if we were talking about volumes of revolution, then it would be pi r squared dx, and this would still be top minus bottom. And what do they tell us in the problem about the axis of revolution if this should be in terms of x? It's around the x-axis or a horizontal line. Okay, so revolving around x-axis or horizontal line. This formula that I wrote out, is that a disk method formula or a washer method formula? Disk, okay. How do I know from the picture that it should be a disk method? Did you guys notice the difference between the pictures? So the shaded region does what? It is touching the axis of rotation, and it's touching all of it. It's not touching it in one spot, it's right up against the axis of rotation, okay? So I'm going to say star shaded region touches maybe I should rephrase that. One whole side of the shaded region touches the axis of rotation. Does that make sense if I say one whole side? Okay, so I'm going to rephrase this. Sorry. Do you guys know what I mean by axis of rotation? What does axis of rotation mean? The line that we're spinning it around. Okay, so if I'm saying rotate it around the x-axis, then the x-axis is the axis of rotation. If I'm spinning it around the line x equals 2, then that line is the axis of rotation. Okay, so for disk method, we have pi r squared. You can leave the pi in here, or you can take the pi and pull it out to the front. I find when I'm doing calculator active problems, I like the process of plugging the pi in there because it helps me with my parentheses to put them in the right place. That's me personally. But I've noticed for multiple choice answers on the AP exam, they tend to take the pi and put it in the front because it is a coefficient, okay? All right, so if we're in terms of y then, that would be from a to b pi r squared, and this is right minus left dy. And how do we know if it should be in terms of y?
It's a rotating around the y-axis.
Yeah, revolving around the y-axis or a vertical line. Okay, so that's the disk method. And then yesterday we learned about the washer method. And what is different about the formula for the washer method? Yeah, there's two. It's pi r squared minus pi r squared. So I'm going to say from a to b of pi r squared minus pi r squared dx. And it's top minus bottom and top minus bottom. And how do I choose which one goes first? Okay, so I'm going to say this one is furthest from of rotation, closest to axis of rotation. Now, one thing that I think confused some people is in a lot of your guys' heads, I think you're thinking it has to be curve minus axis. And the thing is, it could be axis minus curve. So you figure out which way to subtract based on doing top minus bottom. So if you're doing a problem where your curves happen to be above your axis of rotation, then you're going to do curve minus axis. But I think it was problem 14 in the packet, where the axis of rotation happened to be above the curve. And in that case, when we do top minus bottom, we do axis minus curve. Okay? So keep in mind, we choose what goes first because it's furthest from the axis of rotation. But when we do top minus bottom, the curve and the axis can switch places depending on the picture. Okay, and we'll do more of that today. When we flip this back over and do the front side, you'll see that. We'll do a bunch of examples, okay? And then the one in terms of y, we have a to b of pi right minus left squared minus pi right minus left squared dy. Again, when I type these in the calculator, I like to type my pi's in because it helps me with my parentheses. But in a multiple choice problem on the AP exam, they would probably pull the pi out to the front. Okay, so it's good to be able to work with it both ways. And again, this one is furthest, and this one is closest.
Question.
Mm-hmm.
Do you have to subtract the furthest from what the axis of rotation, or is the axis of rotation being subtracted from the furthest?
Both, depending on the picture. So that's what I was saying, is that top and bottom are interchangeable. Mm-hmm. Sometimes the axis is the top and sometimes the curve is the top. So they can kind of switch. And when we flip this over to the front, we'll have both situations. Okay. All right, so the thing to remember about the washer method is that you might have part of the shaded region touching the axis of symmetry, but there is white space. Okay, so I'm going to say there is white space next to the axis of symmetry. It is not right up against it. There's going to be some space there. And that's what creates that washer shape where it's hollow in the middle, because there's some white space. No. I'm guessing that's something like in further along math, like actual college courses. I mean, this is a college course, but like further college courses. Yeah. I personally have never done that before. So.
Because like on the front, like if it said rotated on 4x.
Yeah. So if you look at the front, the only way we could possibly make this into a disk method problem is exactly what Thomas was saying. We would have to revolve it around this line to make it considered a disk method. That is the only possible line you could have where the curve is up against the line, okay? We are not doing that. We're going to reflect it over some horizontal lines and vertical lines, and so that's why this is a washer method worksheet, because no matter what we do, we're going to have some white space, okay? All right, so what I'm going to do is I'm going to draw my lines in pencil because I'm going to draw lines and erase them 6 times, okay? So if you want to have, like, don't draw on pen, or make your paper a little confusing, okay? So the first line that I'm going to reflect over is the x-axis. So this is my line of reflection right here. So is this in terms of x or is this in terms of y? This is in terms of x, okay? Can anyone tell what our interval should be? 0 to 2. Okay, so this is the point 2, comma 8. And you can find that by counting, or you can just find that by knowing that if you plug 2 in, you get 8 as a result. And you can plug it into either of those, you still get the same result. Okay, so that's the 0.28. So when we're revolving it around the x-axis, our interval is 0 to 2. All right, so now we need to figure out which curve is the furthest from the axis of rotation and which curve is closest. So the 4x is furthest and the x to the third is closest, okay? So my big R is going to use the 4x and my little r is going to use the x cubed, okay? Now we know that since the big R is using 4x, we have to figure out what top minus bottom would be. Okay, so we have the axis of symmetry, we're going to use, or not axis of symmetry, but axis of revolution. We're going to use this, and we're going to use the 4x. So if I do top minus bottom, what do I have? Okay, 4x minus 0. What about for a little r? X to the third minus 0. The 0 comes in. The axis of revolution is always one of them. And this time the axis of revolution happens to be a 0. So I'm just putting in the 0. Yes?
Could you explain why the 0 would be in front?
The 0 would not be in front because we're doing top minus bottom. And the 0 is on bottom of both of those curves.
So if it was 8, then it'd be 8 minus 4.
So for example, we can hop down to number 5 next so you can see it.
Okay.
Okay? All right, so now I'm going to go ahead and write my formula out. I have pi big R squared minus pi little r squared dx. So when you type this into your calculator, you have 2 options. You can pull the pi out to the front so you don't have to type it, or you can leave the pi in there. So what I was talking about when I like to put the pi in there, do you guys see how there's already parentheses there? Yeah. That messes with my brain for some reason, that there's like extra parentheses. So for me, it feels like a good rhythm to do pi and then have a set of parentheses that I'm going to square. That for me feels comfortable to type. For me, I get uncomfortable when I have to type parentheses right away, and sometimes I miss one. Does that make sense? So for me, this is the most comfortable way for me to type it. If it doesn't mess with you, then go ahead and take the pi and put it in the front. Okay, either way is going to work just fine. So I just like the rhythm of having the parentheses coming after pi like that. And I am not your calculator, so I should hear lots of typing because everyone's typing this in. So you could type it in with the pi inside, or you could put the pi in the front. So I showed you guys doing it both ways. Either way, you get the same answer. So my first way, I put the pi's inside of the integral. The second way, I factored that pi out like a GCF, and I just stuck it in the front.
Will we get a thing on the quiz, or what we doing?
I think multiple choice problems are no calculator, so they would either be just setting up the problem and not completing it, or making sure it's one where you're going to do the antiderivative and do it by hand. Okay. So 76.595. Okay. All right, how do we feel about that problem? Is that relatively comfortable? Okay. All right, let's do number 3 next, because what you see about number 3 is that we have another horizontal line, but where does that horizontal line show up? This time it's above. Okay. So I still have my interval from 0 to 2. And this time when I figure out my big R and my little r, which curve is the furthest from the axis of rotation? X cubed ends up being the furthest this time. And then which one is closer? The 4x. Okay, so we know that this line is going to go with big R this time, and this line is going to go with little r this time. Okay, so if we're figuring out the big R, we're going to use x to the third, and we have to do top minus bottom. So what should I write? 9 minus x to the third. And then what should I write for little r? 9 minus 4x. So do you see how last time the axis of rotation was underneath the curve, so we did curve minus axis. This time the axis of rotation was above the curve, so we did axis minus curve. See how they switched? So it depends on the problem. They switch back and forth depending on the picture. Okay, so we've got pi big R squared minus pi little r squared and dx, and we're just typing that into our calculators. Ben, you sleepy? What would my 3 decimal places be? Yeah, 600. The nice thing about the AP exam is it lets you round correctly. It also does what's called truncated rounding, where you literally just write the 3 decimal places and cut off the next number, and you don't care if you round up or down, you just write it down. So the AP exam takes either answer as being fine. So if you were uncomfortable, because that's 599 followed by a 6, you could literally write 0.599 and get it right, as long as you had 3 decimal places and not 2. You can have 3 decimal places, 4, 5, 6, 7, 8, 9, 10, but you can't have 1 decimal place and you can't have 2. You have to have at least 3. All right, we good? We got it? Okay. Shall we try one with a vertical line? Okay. So I'm going to go ahead and erase my picture. And I'm going to draw my vertical line x equals 2. Okay. So if we look at this, I'm going to go ahead and rewrite my equations. Since I'm doing a vertical line this time, I need my equations to be in terms of y and not x. So if I have y equals 4x, that's the same as x equals y over 4. Or you could call that x equals 1/4 y. However you want to write it is totally fine. Y equals x cubed. If I wrote that in terms of y, it would be x equals cube root of y. Okay, so these are the equations that we're using. Do you guys have a preference on which equation we have over here? 1/4 y? Okay, we'll go ahead and use that one. All right, so if we compare this to the axis, which line is further from the axis? Which one goes with big R? Yeah, the 4x, but we're going to call it 1/4 y, right? Because we're doing it in terms of y. So this one is furthest, and this one is closer. So here's our axis of rotation right here. This line is going to be a little bit further than this line is. Does that make sense?
Yeah.
Okay. All right, so our big R, and remember, we're going to do right minus left. Big R is going to be right minus left. Okay? So how should I write big R? Wait, be careful. Right minus left. 2 minus 1/4 y. Okay, so we have our interval. Our big R is going to be 2 minus 1/4 y. What's our little r going to be?
2 minus cube root y.
2 minus cube root y. What is our interval for our integral? 0 to 8. Good. So we have pi r squared minus pi r squared All right, and remember when you plug this in, you can use the alpha button to make it y's if you want, or you can make it x's. Your calculator will handle it the same, no matter what variable you use. Or if you want to be like, my name's Miss Rice, so I'm going to use r's every time because that's the best letter of the alphabet, you could do that too. And then you get bonus points. I'm just kidding, you don't. You don't. Yeah.
Can you show us what this one and the last one was like when you spin it around the axis, like in 3D?
Yeah, with the calculator. I can show you the ones that are in terms of x. I can't show you the ones in terms of y because my app doesn't do that. But while you guys work on the rest of this, I'll get it pulled up and I'll show you guys. Okay?
Why is it only black?
Oh, come on. Yeah, sometimes when you're finding these integrals, your calculator has to think for a little bit. That is not necessarily a bad sign. It just means your calculator's having a hard time. Dang it, I need new batteries. Anyone else getting that answer? Yep, 23.457 is perfect. 23.457. Okay, I want you guys to work on the other three, and I'm going to get it one of those pulled up on my little app on my cell phone so you guys can see it in 3D, okay? So if we're looking at like the problem we just did with the, this is like our shaded region down here, if you can see it, and this is like the horizontal line that would be up at 9. This is what your shape would look like when you revolve that. So it's almost like a bowl shape, but a lot of it, since we had all that, when we had our horizontal line all the way up, we had a lot of white space in between. So that means that when we make our volume, it's going to be very hollow in the middle. There's going to be a lot missing as it makes those. So this is like, I don't have very many here, but if I start to add some more of these, you can see that that's kind of the shape that it would make. Does that make sense?